Today's lesson objective is to solve one-step equations. Hopefully this will be familiar to you from last year, but if not, that's okay. We're going to go over how to do it step by step. The standard is to create equations in one variable and use them to solve problems. And we're going to include equations rising from linear functions. We'll get on to more further into that as we progress through the chapter. But the main vocabulary that I hope that you take away from this lesson is equivalent equations, the addition property of equality, subtraction property of equality, isolate, inverse, inverse operations, multiplication property of equality, and the division property of equality. You might notice there's all of these different properties of equalities, property of equality, property of equality. And what we're going to do is we're going to use them to find equivalent equations. So let's just jump into it. First of all, equivalent equations are equations that have the same solutions. And you can think of this again, equivalent starts with the same thing as equal. So it's equivalent equations. They're equations that are equal to one another. They have the same solutions. So in order to solve these equations, we're going to want to isolate the variable. If you think about what it means to isolate yourself from the world. That means you're secluded, you're all alone, you're by yourself. So what we're wanting to do in these problems is we're wanting to get these variables all by themselves on one side of the equal sign. And in order to do this, we have to know what inverse operations do. The inverse operation undoes another operation. So if we have addition, the inverse operation of addition, you already know, is subtraction. The inverse of subtraction would then be addition. Okay, with multiplication, we know the inverse operation of multiplication is division. This might help if I spell it right. And the inverse operation of division is multiplication. So these are inverse operations of each other. Okay, so we're wanting to find a value in this equation that makes x, or a value of x that makes this equation true. So we're trying to solve for x. We have x plus 13 equals 27. Well, if I think back to those vocabulary terms, we had the addition property of equality and the subtraction property of equality. The addition property says that by adding the same number to each side of the equation, it produces an equivalent equation. The subtraction property says subtracting the same number from each side of an equation produces an equivalent equation. So what that's meaning is whatever I do to one side, as long as I do the exact same thing to the other side of the equal sign, then I'm going to produce an equation that's the same thing. So if we think back to isolating, I want to isolate the variable, get it all by itself. That means I need to get rid of this plus 13. Well, that subtraction property of equality just said whatever I subtract from one side, as long as I subtract it from the other, I have an equivalent equation. So if I do x plus 13 take away 13 equals 27 take away 13. I just subtracted 13 from both sides, so I use the subtraction property of equality here. So 13 take away 13, I know, is 0. So this is gone. So I'm just left with x. This is great because I have now isolated the variable. It's all by itself over here. 27 take away 13 is 14. And a lot of times when I do these types of problems, I like to write it vertically. But, I mean, you can do, if you like the horizontal alignment, you could do that. It's whatever you want. But I like to visualize, okay? I'm taking it from this side, so I'm going to jump over here on this side of the equal sign and take it from this one. That I can see is 13. Take away 13 is nothing. Now, I like the vertical alignment for when I'm subtracting. 7 minus 3 is 4. 2 minus 1 is 1. So I have x equals 14. So either way you go, you get the same answer. And then, of course, you can always plug it back in and check. Is 14 plus 13 27? Of course it is. Okay, so now I want you to pause the video and see what you can come up with. What is the solution of negative 7 equal to b minus 3? Okay, I'm going to rewrite it down here. I know that I want to get b by itself. That's my first thing that I always do is figure out what is my variable that I'm trying to isolate. So I'm trying to get the b by itself. So I'm going to have to get rid of this minus 3 up here. How would I get rid of minus 3? Think of inverse operation. The inverse of subtraction we know is addition. The addition property of equality says if I add it to one side of the equal sign, I must also add it to the other side of the equal sign. So minus 3 plus 3 is gone. Negative 7 plus 3. Think of our little song. We're adding, and there are different signs. So we're going to keep the sign of the larger number. And really, I'm just saying what's the difference of 7 and 3? That would be 4, and keeping the sign of the larger number. So it's a negative 4 equals b. You can plug it back in and double check. Negative 7 should equal negative b minus 3, which we know it does equal negative 7. Okay, what is the solution of 4x equal to 6.4? Just like we were doing with the inverse operation of addition with subtraction, we use the inverse operation of subtraction for addition. This time I'm going to go in here and I'm going to find my variable. It's the x. And I'm going to think about what is happening to that x. Well, if I look carefully at this, it's being multiplied by 4. So what can I do to undo that multiplication? What would be the inverse operation of multiplying? Well, the opposite of multiplying is dividing. So the inverse operation of multiplication is division. So I'm going to divide both sides by 4. 4 divided by 4 is 1, which isolated my variable, just left me with x. That's great. I don't need to write 1x because we know that 1 times x is x. And 6.4 divided by 4 is, I'll have to think about this for a second. 4 goes into 6 one time, and then I've got 24 left over. So 4 goes into 24 6 times, so 1.6 would be my solution. 1.6. And you can plug it back in and check. Is 1.6 times 4 equal to 6.4? And it is. 4 times 6 is 24, carry 2. 4 times 1 is 4, plus that 2 makes 6, 6.4. Okay, what is the solution of x divided by 4 equal to negative 9? Once again, I'm going to go in here and I'm going to find my variable. My variable is x. What is happening to x in this problem? Well, x is being divided by 4. So the inverse operation of division is multiplication. And we have this multiplication property of equality that says what if I multiply one side of the equation by a number, it's equivalent to the other side as long as I multiply the other side by that same number. So if I have x divided by 4 equals negative 9, I know the inverse operation of division is multiplication, so I'm going to times by 4. Well, the multiplication property says of equality, do the other side by 4. So 4 over 4 is 1. 1 times x is x. And negative 9 times 4 is negative 36. We can plug it back in and check. Is negative 36 divided by 4 equal to negative 9? Yes, it is. Okay, sometimes you're going to have problems where the coefficient of the variable is the fraction. Remember, the coefficient is just the number in front of the variable. So this coefficient is 3. If I have 2/3 y, this is my coefficient. If I have negative 4/9 z, the coefficient is always the number in front of the variable. So that is, each one of these are the coefficient. But when we're talking about fraction ones, coefficients that are fractions like the 4/9, the 2/3, what this is telling me to do is use the reciprocal. So let's think about what reciprocal means. If I have 2/3, its reciprocal is it's self-flipped over. So it would be 3 over 2. The reciprocal of 4/9, negative 4/9, would be negative 9 over 4. The reciprocal of 1/2 would be 2 over 1. All of these are pairs of reciprocals. So you just take the denominator and put it where the numerator is and put the numerator where the denominator is. And basically what you're doing when you do this is you're getting rid of it because you're making it 1. If I multiply reciprocals together, they should always equal 1. 2 times 3 is 6. 3 times 2 is 6. 6 over 6 is 1. 4 times 9 is 36. I've got a negative times a negative, so I know it's going to be a positive. 9 times 4 is 36. 36 over 36 is 1. 1 times 2 is 2. 2 times 1 is 2. 2 over 2 is 1. So when I multiply by reciprocals, basically I'm just getting rid of that fraction because I'm making it 1. So let's look at an example. 4/5 m equals 28. So I go in and I find my variable that I want to try to isolate. I want to isolate m. I want to get it all by itself. So that means I have to get rid of this 4/5 here. Well, that problem just said I can multiply by the reciprocal to get rid of it. So I'm going to multiply by 5 over 4. Once again, I want to do this because 5 times 4 is 20, 4 times 5 is 20, 20 over 20 is 1. So I'm getting rid of this and I'm getting the variable all by itself because 1 times m is just m. But the multiplication property of equality says whatever I do to one side, I have to do to the other side. So since I multiplied this side by 5 over 4, I've got to multiply this side by 5 over 4. Okay? So I know I'm going to simplify a little bit here that 4 goes into 28 7 times. 7 times 5 is 35. And 1 times 1 is 1, so m equals 35. I can double check myself. 4/5 of 35 is 28. You can type it in the calculator or you can do it by hand. Okay, in biology, just a fun fact for you guys. I really didn't know this till very long ago, but this problem deals with birds. And right over here behind the schools, it's called an estuary because every year people come from all over the state, really, to watch birds migrate. Because our little area back here behind the schools is an estuary. It's where close to where the Soda River flows into the Ohio River. I don't know if that has anything to do with it, if that's why all of these birds migrate through here. But when they're flying south for the winter, this is a big area that they stop to eat and different things. So just a little fun fact for you that if you are interested, a lot of people come down Moore's Lane and park to go bird watching. But anyway, toucans and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 the length of an average blue and yellow macaw. Toucans are 24 inches long. What is the length of the blue and yellow macaw? So let's identify our important information here. We've got the toucan, and we know that it's about 24 inches long. And we've got the macaw. We don't know its length, so let's let its length be W. Okay, so the toucan is 2/3 the length of the average blue and yellow macaw. So if the macaw is length W, then we know that the toucan is, what did it say? 2/3 the length of the macaw. So it's 2/3 the length of W. So we know two things about the toucan. Right now we know that it's 24 inches, and we also know that it's 2/3 the length of the macaw. I don't know why I put a W. I was thinking M, but that's okay. We'll stick with the W since I wrote that. So these are equivalent equations. The toucan's length is equivalent to 2/3 of the macaw's length. So now we want to know what is the length of the macaw. Well, this is a fraction, so I want to get rid of it to isolate my variable. So in order to get rid of this fraction, I'm going to multiply by its reciprocal, because 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1. Well, whatever I do to one side, I multiplied this, I've got to also do to the other side. So I'm going to multiply by 3 over 2. 24 divided by 2 is 12. 12 times 3 is 36. So the length of the macaw is 36 inches long. Now let's make sure that makes sense in terms of the problem. Which one should be longer, the macaw or the toucan? Well, it says the length of an average toucan is about 2/3 of the length of an average blue and yellow macaw. So we know that the toucan should be shorter. So that makes sense that the toucan is 24, the macaw is 36 inches.